Okay, this first one up here, what's our solution definition?
A homogeneous mixture made up of two or more substances.
That sounds great. And the solute and the solvent, how are those two guys related to each other?
The solute is the thing in the lesser amount, present in the lesser amount of the solid. Yeah.
Okay, so somebody posted something about vinegar last night, or yesterday, or whatever it was. So it's acetic acid and water, and which of those two things is the solute? The acetic acid. It would not be consumable if it was the other way around. If it was 95 or 94% acetic acid, you wouldn't even want to get anywhere near that. Describe what happens to the solubility of a solid as the temperature decreases. Okay, so solid, so something like table salt as the temp goes down, or what do we end up happening to its solubility? It decreases. Okay. So why is that?
Because the water has less energy to hold on to it.
All right, that's good. So the solubility decreases because less kinetic energy, so it takes more of them to hold individual ions. What about when the temp goes up for a gas? Solubility also decreases. And why is that?
Because it's evaporating.
Yeah, it just simply, it's the solute gas has enough kinetic energy. Just leave. And the solids don't have that option because they can't be gases at those temperatures. So what's the equation for the molarity?
Moles of solute over liters of solution.
And so then your units are going to be
Moles per liter.
moles per liter. Okay. What's the concentration reported in units of molarity when 140 grams of potassium iodide is added to make 100 milliliters of solution? Okay. So I need moles per liter, and what I have right now are grams and milliliters. So 140 grams of potassium iodide in 100 milliliters. So I'm going to get rid of the milliliter part first. And then I need to get rid of I need moles up top, 1 mole of potassium iodide, grams potassium iodide. So 39.0983 plus 126.9045. So I got 166.003, and this will be moles Ki per liter, and so 140 divided by 166, so I got 8.4. Looks like I only have 1 sig fig, so 9 molar. Will that potassium iodide dissolve at 20 degrees Celsius? About 10 degrees Celsius. So what do you need to be able to answer that question? Yeah, you need the notes. Need this guy here. And so at, so here's 0 degrees, here's 10 degrees, here's 20 degrees. So at 20 degrees, can you fit all 140 in? Yeah, you can fit like 144-ish. But at 10 degrees, you can only fit about 135. So I know you should see, so yes for this one. Oops. What's going on? What are you doing? Great. Let's go back to this. So yes at 20 degrees Celsius, and no at 10 degrees Celsius. There should be 5 grams of Ki solid in the container. Explain how you'd make 250 milliliters, 0.35 molar sodium hydroxide. All right, so first thing I need to know is how many grams of sodium hydroxide that I need. So I'm going to go with 0.35 moles per liter, and I've got 0.25 liters. So 0.35 times 0.25, I get 0.0875. Really? Gram? Oh no, that's not what I want to stop. Sorry, that's not just going to give me moles. And then I got to use the molar mass. So it's 22.9898 plus, what is this? Hydroxide? 1.00795 plus 15.9994. And so I get 39.992 or 72 grams. All right, I put that in the wrong spot. 1 mole. 39.9972 grams. Okay, so that times a quarter times 0.35. So I get 3.5 grams NaOH. So I'd say put 3.5 grams NaOH in 250 milliliter vol flask. Then 3/4 fill, mix, fill near line, fill 2 line with dropper. And how about the molarity and molality? What's the main difference between those guys?
Volume versus mass.
Yeah, so this one, this is a volume base unit, and this is a mass base unit. So what's good about the molarity?
It's more exact. No, it's, you can use it when not looking.
It's cheaper
Okay. That one.
and it's easier. And this one is more exact, but more expensive. Considerably more expensive. Okay.